In this video, we'll be talking about projecting data in PostGIS. In the last videos, we already talked about how to work with geometries and how to analyze the spatial relationship between geometries. And sometimes these geometries might come with different projections. And one common operation in GIS is that you might need to transform the projection. So basically you might need to reproject the data so that all the data are in the same coordinate system or projection so that you can work together. Otherwise, when you open some data, for example, in desktop GIS, QGIS or ArcGIS, you might sometimes encounter a dialog showing that, okay, your data have no projection or are in a different projection than the base map and asking you to transform. Similarly, in PostGIS, you can also reproject the data, and it's actually very easy to do. So this is what we're going to talk about in this video. And first, let's go to the website to download the notebook example we're going to use in this tutorial. So go to the postgis.gshub.org and then click the number 6, projecting data. Upper right corner here, click the download the notebook to your computer. I'm going to download to my downloads folder, and then you can open your terminal or Anaconda prompt. I'm just going to right click, open in Windows terminal, and then you can activate the Conda environment. So Conda activate SQL. Oops, or Conda, there's a typo here. And then just type Jupyter Notebook, enter. Click projections, the Jupyter Notebook, then you should have this one. And so in this video, we have a couple of sections. You can click the table of content here to show the sections. So we have 5, and we're going to go through one by one in here. First of all, let me clear all the outputs so we can restart and clear all the output. And then the first step is the same as the previous video. We need to connect to the database. So if you already have PGAdmin open on the left side here, if you click the NYC, right, and you should be able to see all the tables within this database. I'm going to just to select here and then cell run all above. It's going to connect to the database and then show you some sample data. For example, the NYC subway stations table. And here you should be able to see this one. Similarly, you might want to, for example, in the PGAdmin, you can also do it from here. NYC subway station, right click, and then view data, all the rows, right? So here, you'll be able to see similarly the table. And one thing that you might want to use is the geometry. So the new PGAdmin right now, actually, you can view the geometry because traditionally the PGAdmin is just for viewing this kind of a tabular data, but you can also actually view the geometry. So if you click this one here, this icon, view all geometry in this column, and once you click, you will be able to see the geometry. You can zoom in, you can zoom out, right? So this is pretty nice, but the background is like just blank. There's no base map, and later I'm going to show you how to actually project the data so that you can load the base map. You'll be much better. So this is one way you can view the geometry. Similarly, oh, by the way, so because the data is not in the WGS84 longitude and latitude, then that's why the base map does not show up. You can click any switch spatial data layer. So right click again, view data, all rows, and then similarly you can click this icon, the geometry icon. You will be able to actually view the data. So this one is NYC suite data. You will be able to see all the layers. So this is nice. If you don't have access to desktop GIS, for example, QGIS or ArcGIS, you can actually view the geometry directly within the PGAdmin without having to install desktop GIS. So this is some of the very basic thing you can view the geometry. And again, I'm going to show you how to load the base map later. For now, this is showing you the way to view the geometry within PGAdmin. Okay, so the first thing what we want to do is to actually to check the projection. So all the data on spatial data must have some kind of a spatial reference. So SID represent spatial reference ID, and so you can data can come with different projection, different coordinate system. So one thing that we want to do is actually to check the data, see what the data spatial reference is. So in PostGIS, every record, every row represent one geometry. So that geometry, it can actually have different projections. But traditionally, if you have a vector data data set, for example, a shape file, it will be just one single projection or coordinate system for the entire file. But in the PostGIS, it's basically individual records. So each record actually can have a different, but most of the time they will be the same. And if we look at this one here, there's a function STSRID. Again, you can go to the PGAdmin. If you want, you can look at the functions. So if you click here, functions, you should be able to see all the PostGIS functions here. And you can scroll down to see the ST function. So ST and then SRID. So if you scroll down all the way somewhere to the end, where is it? STSRID. So this one here, geometry, right? So this is how you can retrieve the spatial reference ID. So if you click here, we're trying to figure out, for example, the NYC street spatial reference ID. So all the data is basically, if you look at this one here, we have the geometry column, and it just limits one. That means we're just going to show just the geometry, a spatial reference ID for just one, the first row within that file. So if you execute, it will show you 26918. This one is the spatial reference ID, is the EPSG number, and that the EPSG it represents the projection or the spatial reference ID for that specific geometry. You can certainly read all of them if you want. So for example, you can limit, let's say 10, and then you shift enter 10 and then control enter. You should be able to see all the spatial reference ID. So everyone for one individual object, and they're all the same because the file we imported from a vector shape file. So all the rows are basically we set as 26918, and this one is a number. But how do you know what this one actually is? Because it has a number, there must be some meaning representing this number. So you can look at the previous section, how to load the data and how we specify this one. Every spatial reference ID, you can find information from the spatial REF systems table. Again, let's go to the PGAdmin, and you can look at the table. So okay, here the tables spatial REF SYS. If you right click, view all rows, and then you should be able to see all the information, right? So this one has 8,500 rows, so there's a lot of spatial reference ID. You can scroll down, you can try to find the number that you want, but in this case we were just going to select that specific number out of the spatial reference table. Okay, so select start from this table where SRID equal to 26918, right? So it has a column here, SRID. So this one represents the number, and basically we're trying to select the row that meet with the spatial reference ID equal to 26918, right? So just shift enter, then you'll be able to see the return result, right? So SRID, also name, SRID, right, 26918. The most important thing here is the last two columns. The first one here is SR text. The second one is projection for text. So this one here, SR text, this is something commonly used for other by other desktop GIS, for example, QGIS or ArcGIS. And the second one here, projection for text, this one is used here internally by PostGIS. So when you're trying to do projection, it's going to retrieve this information and then do the projection based on the project for text. All right. So how can we actually retrieve this one from this column? You can also similar to this one, for the start you can just select single column, right? So select projection for text from this spatial reference system table, where the spatial reference ID equals to 26918. Then you're going to get just this simple text. So this one represents the spatial reference ID 26918. As you can see from here, plus projection equal to, okay, so this is UTM projection, and then the zone is 18, north 18, datum NAD 83, and the units equal to M, like this. So this is basically a standard format for the projection for text, and this is how I can retrieve the projection for this. Keep that in mind. So you have the data, you have any data. Once you get the data spatial reference ID, then if you want to retrieve the SR text or the projection for text, you can just select from this spatial reference systems table. Again, it has 8,500, so all of them will be in there. Most of this is using the EPSG, so the European Petroleum Standard Group. Okay, so if you go online or use any other web mapping, most likely you'll be encounter this EPSG number. And one of them this very commonly used is the coordinate longitude latitude WGS 84. That one, the EPSG number is 4326. That one you probably need to remember. Okay, so next let's see how we can compare the data. But in order to compare it, in the last video we actually already compare with the geometry. But keep that in mind, if you try to compare geometry, make sure they have they have the same spatial reference ID. Otherwise it won't work. So in this case, this example I commented out because it will throw errors. This notebook won't be executed if I put this one, but I'm just going to show you here the example. All right, so if you're trying to compare, this is a point, and then you passing a spatial reference, right? 4326. This one is the leg long WGS 84, and then you're trying to create the geometry from this one. The other one is the geometry is the same coordinates, but it's a different coordinate system. These two are not the same point, apparently, but you cannot use this function trying to compare because they are not using the same spatial reference ID, right? So you cannot compare these 2 points. And so in order to make sure that data have the same projection for your project, then somehow you need to reproject the data, or so-called transform the data. And as we show here earlier, the dataset we have been using, the NYC dataset, has a spatial reference ID 26918, right? So if you're trying to export the data or you're trying to do the reprojection, you might want to use something like standard. So for example, you can convert the data to geographic coordinates 4326. So again, it's long latitude and longitude WGS 84 spheroid. And if you want to learn more information, you can go to the spatial reference website, and you should be able to see the content in here. So it's the same projection, right? So this one represents the projection, but it depends on the software packages they are using. It's actually going to generate multiple different format of files. So if you look at this one here, this is basically the output, right? This one represents something, but it's going to be interpreted differently by different software using different formats. So you can, for example, PRJ, right? You'll be look like this. If you look at, for example, the Esri WKT, you'll be look like this, right? So every software packages or something, they might have use different standards, so you'll be very different. But eventually they're using the same data set, right? It just depends on how you want to transform this one to a text that can be recognized by that software package, right? So you can click here. You can do the search here on this website to find anyone you like. Again, spatial reference, I can just here type here 26918, hit enter. Then if you see this one, do you mean EPSG 26918, right? If you click, it's going to show you here NAD 83 UTM zone 18N, And so apparently this one is the UTM projection, and it covers the NYC area and in North America. You can also see the longitude, latitude, something like that. You can look at the PRJ for text, right? So this is the one. We can later see if this is equal or not to the data that we're trying to work on. So first, let's take a look at the spatial reference ID, how we can get the SR text and also the projection for text, right? So this is one of those. You just shift enter. It's going to show you this is the SR text, right? Spatial reference text. This one is used, for example, by QGIS or other software packages. And let me find this one here, see if we can find it, right? 26918. You can just try this one, right? Projection, blah, 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 blah. If you look at this one here, GOS, right? And then WGS 84, datum, WGS 84. Kind of similar to this one here, GCS, Geo, right? You can also return the projection for text, right? I can just create a new cell block below, and I'm going to just copy this code block. From here, I'm just going to use PROJ for text. PROJ for text. Shift enter. You'll be like this. PROJ let long. Datum WGS 84. No. Right. So this is for the 4326. Again, I can go back to the website. Just type 4326, hit enter, and it will be the first one here. So you can click the project for, right? So this is the information. You can get that directly within this spatial reference table. And if you run the notebook, you will get the same results. This is how you can retrieve the spatial reference information. Next, let's take a look at how we can actually transform the data, basically do reprojection. So in order to do reprojection, we need some data. So here we're going to use the NYC, for example, subway station. But first, let's look at, before you do the projection, what the data look like, what kind of a coordinate it is, right? So you can run this one, and then here select ST as text, right? The geometry. We're trying to get the human readable coordinate from the points and from the NYC subway station, where the name equal to Broad Street. That means we're just trying to select just one single station, a subway station from there, and then just convert it to a human readable, right? So points, and then this will be XY. So it's a pair. But if you look at this number, it's huge because this is not a coordinate. WGS 84 latitude and longitude. So in order to see to convert that, you can add something here. This very much similar, except the first line here, ST as text. We are going to actually within there, the geometry, we're going to convert the geometry. So to transform the geometry, the function is called ST transform, and the first argument is the geometry, right? So this is the geometry, and the second one is the SRID number. So we are telling PostGIS to, okay, get the geometry, convert it to let long, and then get the number, and then display the number. That's it. So shift enter. Now if you see this one here, point negative 74.01 and 40.7 here, this is basically the longitude and latitude in here. So if you compare this one to this one right now is using the lat long, so it's much easier to recognize. So again, longitude and latitude, right? So negative here is in the western, so this is in the US, and positive, this is latitude in the northern hemisphere. And this is how you can convert the geometry. We're here, we only do one, but you are welcome to convert the geometry for all of them. So if I just delete this one and then control enter, you will be able to see all the points. So these are the entire records, right? Depending on how many you have, you're going to convert all the points automatically from the UTM 18 to longitude and latitude. So this is very nice. Just one line here. If you can use desktop software, you might need to just run the two, and it might take a couple of seconds, but here it's also very powerful and very fast. Again, this is how you can convert the projection. So next, let's show you how you can view the geometry using the PGAdmin, right? So let me just copy this one and just to show you how we can do this. So copy this one. So these two lines basically trying to convert to reproject the data to longitude and latitude, WGS84 from UTM, right? So in order to see the base map, you need to convert the data to using this way. So copy these two lines and then come back to the PGAdmin. Next, I'm going to show you how we can actually view the data with the base map. So if you go to, again, NYC subway station, right click, and then click query to. So from here, you just paste the command that we use, right? So what does this mean? We are going to transform the NYC subway station data from 26918 to 4326, and then you can, if you want, you can show the text if you want. Okay, and there's a seat one. So we have this one. Oh, but we don't need the text. We can just simply remove this. So we just convert the geometry. We want to keep that column as geometry because otherwise you won't be able to see this icon. So once you convert to geometry, then you can click this one. Right, you can see the geometry. You can see the geometry, but you can right now also see the base map. So this one is very important. In order to see this base map, this is based on leaflet or probably a folium or something like that. So you can right now you can select different base map from here, right? So from the street, if this one is not 4326, you won't be able to see this one. So make sure that you convert this one. So this is for the subway station. Similarly, you can do that for other data. Again, let's try, for example, NYC street. Right click and then query to, paste, right? And so this one here, we want to change the name to NYC, and then you can shift control space. You can select the table you want, then execute, click this icon. You should be able to immediately see the base map. You can zoom out, you can zoom in, and this is very nice because you can right now view the data. You can take a look at the data. You can turn the layer on and off. So again, if it's just this original one, you won't be able to see this one. So right click and then view the data, view all the rows, and click this one. It will just be the empty base map, right? So you don't know exactly where the data are located. You always want to convert to longitude and latitude in order to be able to see the base map. So this is how I can view the base map. And next, what else? So this is how you can convert the projection, reproject the data to any projection you want, right? As long as you can find the spatial reference ID. So depending on a specific application, and you can always find the one to that's best suited for your application. And then once you get the number, you can do the conversion just simply using something like this: ST transform, geometry, and then this is the spatial reference ID that you want. That's it. You can also look at, for example, if you want to see the spatial reference information for all the tables within your database, you can also do that. One thing is to look at the PGAdmin and then schema, public schema, and then look at the end views. So this one here has geometry columns. Right click and then view data, all rows. Here you should be able to see all the spatial reference, right? So in this case, we have 7 tables. The last one here, this one is the built-in one. So we actually have 6 data layers, 5 for NYC. The other one is the geometry that we created in the last video. If you look at the table here, the geometry table, and look at this one here, the spatial reference ID, right, to 26918, all for the NYC data, except for the last one here, the geometry, because the geometry is the one that we created without specifying any specific spatial reference ID, but all the others is 26918. Very nice. Similarly, you can do that using the Jupyter Notebook. If you want, you can select F table name as name and also the SRID. So basically we're trying to select these two columns out, right? So the table name is F table name and also the SRID. F table name, so if you use S, that means you're going to create an alias. So the table name, the column name will be changed to this one, and then from the geometry column table, right? So now you have the column name is name and SID. So this is exactly the same as the one you see here from this table, but except you only see the two columns. Okay, so this is how you can view all the spatial reference ID for all the data set, all the tables within the database. Similarly, you can also do the conversion. So if you want to, let's say you want to convert one table, the spatial reference from one to the other, you can do that using this way. You also need to use the ST transform, and then you can set the spatial reference ID, right? So if you don't know exactly what the ID is, you can assume that sometimes the data it has the spatial reference ID, but in some unknown reason that the spatial reference ID was not recognized or it was lost, then you need to set the spatial reference ID. In that case, you can use this function st set SRID, and then again the geometry, the SRID number. And so this is how, after you set the spatial reference ID, it becomes a geometry with spatial reference, and then you can do the transform to longitude and latitude. Then you can display the text, right? So you can hit one, you'll be able to see something like this. So this is example we created used in the previous videos, how to create a point, a line, a polygon, and polygon with a hole, and also a geometry collection, right? So this is how you can deal with that. You can basically transform the data. You can assign a projection to a data set, and then you can also transform the projection from the data set whatever way you want. Lastly, here are some functions. So in this video, we talk about this function we already used in the past, st as text, but we have the new one here, set spatial reference ID. Also, we can get the spatial reference ID, or we can also transform. So these are the only three functions that we cover here in this video. The other nice feature that we introduced is the geometry viewer. Again, if you want to see that, you can you need to transform the data in order to be able to see the base map. So this is a nice way that you don't have to rely on desktop.js to view the geometry, to view the base map. In the next video, I'm going to show you how to use GeoPandas and IPylib that actually to view the data from the PostGIS query, right? So you can get the data out of this database and then display on some other web applications, because the PGMin, sometimes you might not have access to the PGMin, because this one is just limited to the one who have access to admin to administer the database. If it's just a regular viewer on a client, you might not have access to this one, but you can still do the query. But how can you get the data out? It's one very important thing that we need to address. Okay, so that's all for this video. I will see you in the next video. Take care. Bye bye.